prove that for all positive integers a and b, the GCD of a and b equals the least common multiple of a and b if and only if a equals b. So to prove this, we have to prove a biconditional statement, which means we need to prove two separate implications. We'll start with the backwards direction, which means we're going to assume a equals b. Then the GCD of a comma b is the GCD of a comma a, since b and a are the same. And the greatest common divisor of a and a is just a. Meanwhile, the least common multiple of a and b is the least common multiple of a and a, since a and b are the same numbers. We can substitute b with a, and this is just a. And so the greatest common divisor is a, the least common multiple is a. This means that the greatest common divisor is equal to the least common multiple. So that proves that direction. Now let's prove the forward direction, which is harder. Now what's important here is that the greatest common divisor of a and b is a divisor of a and b, meaning that this number divides a. A is a multiple of this number, but at the same time, this GCD is a least common multiple of a and b. So this divisor is also a multiple. So on one hand, a equals the greatest common divisor of a and b times some integer k, but at the same time, the greatest common divisor is the least common multiple, and so the greatest common divisor is a multiple of a. So the greatest common divisor of a and b is a times some number x, where x is an integer. Next, we can substitute a times x into the equation above to get a equals a times x times k. We could divide both sides by a to get 1 equals x times k. Now, since x and k are positive, then that means that x equals 1, which is also k. And so this means the greatest common divisor of a and b is actually a. Now we can do the same trick, but instead of using a, we can use b to show that the greatest common divisor is also equal to b, which means that a and b are the same. And that's what we wanted to prove. Thanks everyone, and I'll see you in the next video.